Hello, welcome to another pre-calculus lesson. I'm sure you have been waiting and waiting for this day to come to be able to do another pre-calc lesson. So here it is. And of course my handwriting is awful, so I got to fix that letter I. Okay, so we're doing lesson 7.4, solving simple trigonometric equations. But just like solving algebraic equations, the goal is to isolate the variable. It's just going to be in trig equations. We'll be using inverse trig functions. So like with regular equations, go to basic algebra. If you have 2x minus 1 equals 7, you'll do the inverse of minus 1, which would be plus 1. Do that to both sides of the equal sign. And the inverse of times 2, which is divide by 2, you get x equals 4. So same thing, we'll just be using the inverse trig functions. Now there are 6 trig functions, so there are technically 6 inverses, but on today's lesson we're just going to stick with the main 3, just in the name of simplicity. So sine, cosine, and tangent. We have sine inverse, cosine inverse, tangent inverse. Excuse me. And I'll show you how to use those as it comes up. As we do these, I'm going to be illustrating the difference between using a calculator and the unit circle to solve these. And we'll find that the unit circle is best for our application. And we're going to be finding solutions between 0 and 360 or solutions between 0 and 2 pi. Just depends on if you're doing radians or degrees. And boy, that is awful as well, 360 degrees. So some of the problems will be in degrees, others will be in radians. Now, these are simple. Tomorrow, or whenever you do the next lesson, those will be more advanced. So the advanced ones will have a lot more steps, and they are going to use the other trig functions besides sine, cosine, tangent. So cosecant, secant, cotangent. But for today, that's not the case. The first 2 are super simple. So I'm just going to do one, and I'm going to leave you to do one. And then after that, I'm sorry, the first 4 are super simple. And then after that, they get a little more complex. Now I'm seeing that both of my examples are sine problems, which was kind of dumb. You have a sine problem and a cosine problem. I think you'll be okay, though. Ideally, I demonstrate a little more variety, but I don't think it'll be too much of a problem. And then when we get down here into these problems, I have sine, sine, tangent, cosine, tangent, sine, tangent, cosine. So I've got variety here anyway. And if you look at your assignment, cosine, tangent, cosine, cosine, sine, cosine. Okay, you have a lot of cosines, but it's okay. It's all good. It'll work out just fine. All right, so let me start with number 2. Of course, I'll do the evens, you do the odds. And it says find solutions for theta between 0 and 360, including 0, not including 360. All right, so here's our equation. Sine of theta equals negative 1/2. Remember, theta is a variable. It could be x. It could be any variable. Solve for x, solve for theta, same thing. So we need to do, to solve for theta, we need to do whatever it takes to cancel out sine. Now a lot of students' first instinct when they see this is, oh, divide by sine. Well, this is not sine times theta. You can't divide by sine because it's not times. Sine is not a number, it's an operation. So to solve this, we need to do the inverse. I'm going to rewrite the equation like so. Notice I'm leaving a space here, kind of like we did with logarithms. Because to solve this, you need to take the inverse sign, and you have to do that on both sides of the equal sign. The inverse sign over here cancels sine out. The other side, inverse sign of negative 1/2, should be our answer. Now I am going to use the calculator on this first, just to demonstrate how that would work. So I need to do the inverse sign of negative 1/2 on the calculator. Well, first I'm going to hit the little wrench up there and make sure I'm in degree mode. That's important. Then I'm going to go to functions. The inverse sign is top center right there. And then type in negative 1/2. And I get negative 30 for negative 30 degrees. Excuse me. Now let me check the answer to number 2. And that is definitely not negative 30 degrees. So this is weird. It could be negative 30 degrees if this said solve the equation for theta. Let's say it might be something like theta is between negative 90 and positive 90 degrees. That's a thing that could be, or something like that. So negative 30 does fall between negative 90 and positive 90. solving trig equations can be a little complicated because there's different ways to interpret the answers. The calculator gives one specific type of interpretation, but it only applies to certain instructions. So, boy, that's confusing. Let me eliminate the confusion, get rid of that, and bring up the unit circle. Let's see, now how do I want to do this? There we go. Yeah, that'll work. So, let's not use the calculator answer and say, all right, inverse sine of negative 1/2 on the unit circle. How do we do that? Well, remember, on the unit circle, sine is a y value, right? Do I have that written down? I don't. So, oh yeah, right up here. The unit circle is cosine is the x value, sine is the y value. Of course, tangent is sine divided by x. Well, actually, y divided by x. So, what I want to do is I want to go to the unit circle and find a y value that equals negative 1/2. And where does that happen? Where does that happen? You know what? This would be nice if I could highlight this. I can't write on that. Well, okay. Here's what I'm going to do. I'm going to just zoom in with my fingers, and then I'll try to import this to the actual assignment that we're doing. All right, so where is a y value equal to negative 1/2? Well, do you see right there, that coordinate, square root of 3 over 2, comma, negative 1/2? And that is on a 330-degree angle, so that means 330 degrees is an answer. And then if I zoom around the page, I find again a y value that's negative 1/2. So right there, negative square root of 3 over 2, negative 1/2. And that happens at 210 degrees, which I'm going to put first because, you know, numerical order. 210 degrees and 330 degrees are two angles on the unit circle that have a sine value or a y value of negative 1/2. Therefore, those are the solutions to that equation. Let me again scroll down to the answers, and there it is. So the overall point I'm trying to make is the calculator can solve the equation depending on the type of solution you want, but these directions are set up in a way that we want the solutions that only come from the unit circle. Okay, I'm going to do plus sign, photo library, all photos, and I have to scroll through and, oh, that's not what I want. What am I doing? Plus, photo library, all photos. Oh, okay, I gotta scroll down. And where's my unit circle? Right there. So now, this is something I can write on. Oh, I'm having such a hard time here. Just trying to blow it up so I can make it easier to see. Okay, so the downside is I'll have to scroll up and down a bit, but to do this problem, let's go up here. So x is always a cosine value, y is a sine value, tangent is a y divided by x. That's how you read the unit circle. Go back to the unit circle lessons. If you forgot, you can review that. So if we have the inverse sine of 1/2, what we're saying is we want to find a y value that equals 1/2 because sine and y go together. Right here is where that happens, so that's 330. And right here is where that happens, so that's 210. There's no other points on the unit circle that have negative 1/2 as a y value. There's this one, but that's positive 1/2, so that doesn't count. Now, real quick before I go on, if you look at 330, 330 is equivalent to negative 30 degrees, which is the calculator answer. So the calculator answer is just a different interpretation. It's not technically a different answer per se. It's the same answer, but it's only one of them, and it gives you the negative version instead of the positive version. And we're not going to worry about why right now. That's a whole extra lecture. So let's just do the task at hand. Okay, so number 4, sine of theta equals 0. So I need to do the inverse sine of both sides, and I guess I'm too lazy to rewrite the whole problem like I did up here. I rewrote the problem like that. Whatever, do what you're comfortable with as far as showing your work. I need to do the inverse sine of 0. Inverse sine of 0. So again, I need to find a y value that equals 0 on that unit circle. Can you find a y value that equals 0? And at first I looked right here. That's an x value. Duh. It's got to be here and here. So it happens twice. Now the first one, oops, over here, this point goes with 0 degrees or 360 degrees. Or, oh look, the directions tell us to use radians. So whatever, that's no big deal. This one goes with 0 radians and 2 pi radians. And then this one goes with pi radians. So I might be tempted to put down, okay, the answer is 0 radians, pi radians, and 2 pi radians, because those three answers are all on my unit circle. But if you look at the directions, it says theta is possibly equal to 0, right? There's an equal sign there, but there is no equal sign to 2 pi. So we're not going to count the one where theta equals 2 pi. We'll just get rid of that. And our two answers are going to be 0 and pi. Oh wait, why did I write the answers over there? That was kind of dumb. The answers go over here. Theta equals 0 and pi. So let me scroll down to number 4. I feel like I'm doing nothing but mistakes right now. Right there. Okay, so that's how you do those. And I consider these to be simple because to solve them you only do one thing, the inverse trig function on both sides of the equal sign. You look at something like this and there's more steps. You've got this 2 here. So to solve this equation, I need to start by subtracting 2 on each side. I get sine theta equals 4 minus 2 is 2. Then to cancel out sine, I need to do the inverse sine of both sides. I get theta equals the inverse sine of 2. In other words, again, man, I wish I wasn't doing all these sine problems, but sine is equivalent to a y value on the unit circle, so I want to find a y value that equals 2. Let's go up to this unit circle. I'll erase some of these other marks I made, and scan through all of the y values everywhere on the unit circle. Are there any y values that equal 2? There are not. In fact, for a y value to equal 2, if we look at this as the y-axis, that would have to be like way up here. 0, 2, and there is no, I mean, that's not on the unit circle. So the point is, the fact is, this equation should have no solution. Or remember, that's a symbol you can use for no solution. Not to be confused with theta, which has a horizontal line, but that's the no solution symbol. So let's look at number 6 and see if that's true, and there it is, no solution. All right. Number 8. Oh, another sine problem. What did I do here? All right, anyway. How do I solve this one? Would I add 2 to both sides because this is minus 2? No, that doesn't work. It's actually not subtraction. It's negative 2 times sine. So what I need to do is divide by negative 2. To cancel that out, you get sine of theta equals negative 1/2. So again, sine is y. We're trying to find a y value that equals negative 1/2. Where is that at? Where does that happen? Well, geez, we've just done this problem. Right here and right here. 330 degrees and 210 degrees. So number 2 and number 8 are essentially the same problem, except there was an extra step here. But the answer is 210 degrees and 300 equals, comma, 330 degrees. Let me check number 8 and make sure I didn't mess anything up. And there it is. All right, let's move on to number 10. Now these instructions say give an answer between 0 and 2 pi, so we have to give an answer in radians. How do I solve this equation? Well, that's 1/2 times tangent, so I guess I need to divide both sides by 1/2 to cancel that out. 0 divided by 1/2 is just 0, because, I mean, 0 divided by anything is 0. So tangent equals 0. Now how do I do a tangent? Well, not yet, I'm sorry. I need to cancel out the tangent. What cancels out a tangent? An inverse tangent. So I need to do inverse tangent of both sides to get theta equals the inverse tangent of 0. So let me do the inverse tangent of 0 on the unit circle. Now right up here I have a little note, tangent equals y over x. So let me go back down here. I'm trying to find a y divided by x that equals 0. So where on this unit circle can I do y divided by x and get 0? Well, it can't be any of these points. It's got to have a 0 in it, right? It can't be any of those. It's got to be one of those quadrant points. So here, if I do y divided by x, that's 0 divided by 1, which is 0, which means 0 radians is one of the answers. So theta equals 0, that's one of the answers. Could there be more answers? Let's go up to this point. Y divided by x is going to be 1 divided by 0, but in mathematics you cannot divide by 0. This is undefined. If it's undefined, undefined is not the same thing as 0, so we do not count that angle, pi over 2. Let's go to this one, right here. Y divided by x is negative, sorry, we're just about to do that wrong. 0 divided by negative 1, 0 divided by anything is 0, so that makes pi an answer. So down here, pi is an answer. Sorry about all the scrolling up and down. I really wanted to have this split screen, but if I split the screen, I can't write on the unit circle, and I think it helps to write on the unit circle, so it's what we have to deal with. Okay, so this point down here, that's x, that's y. Tangent is y divided by x, that's negative 1 divided by 0, but again, dividing by 0 is undefined. Therefore, this one is not one of the answers. So my only answers to number 10 should be 0 and pi. Let's check number 10. And there it is, 0 and pi. Let's go on to number 12. Oh, a cosine problem, finally. Well, okay, so we didn't do all sine. We did a tangent here. Here's a cosine problem. So how am I going to do this? I believe I need to start by subtracting 2 on both sides of the equal sign. I get cosine of theta equals 1 minus 2 is negative 1. Now I do the inverse cosine of both sides of the equal sign, right? Inverse cosine cancels out cosine. Do it to the other side. Theta equals the inverse cosine of negative 1. Sorry, make that look like, there we go. What is cosine on the unit circle? Cosine on the unit circle is the x value. So we're trying to find on the unit circle an x value that equals negative 1. All right, let me erase a bunch of this mess. There we go. Okay, so just visually scan through, look at all the points till you find an x value that's negative 1, and it's right there. Are there any others? That's a y value, that doesn't count. That's a, no. That's the only angle, so it's got to be pi, or 180, depending on whether the question is in degrees or radians. I believe at this point we are, oh, there we are in degrees. Nope, we're on this problem, sorry, still radians. So theta equals pi. That should be the answer to number 12. And there it is, pi. So you see, sometimes you get, excuse me, 2 solutions. Sometimes you get 1 solution. Sometimes you get no solution. That can all happen. All right, number 15, 14, 13, sorry. Number 14, getting a little more complicated here. And our answer needs to be between 0 and 360, so we are back into degrees. Now this is kind of a big mess. One of the tips we can do here, we've used on other types of equations, we can clear the denominators. You get a couple of fractions in an equation, you can just multiply everything by that denominator, and it'll make it a lot easier. So if we distribute here, before we can distribute it into the numerator, that 5 is going to go ahead and cancel out with the denominator, and we get this. If we distribute here, 5 times 1/5 cancels. We get 1 times tangent x, or tangent theta, which is just tangent theta. And if we distribute here, 5 times negative 5 is negative 25. So this whole equation becomes negative 25 plus tangent theta equals negative 25 minus 3. So we clear the denominator by distributing a 5 through the whole thing. So now what? Well, we can get like terms together. So I want to add 25 to both sides. I get tan theta equals negative square root of 3. And at this point, to isolate theta, I'll need to do the inverse tangent of both sides. Cancel that out. So I want the inverse tangent of negative square root of 3. Now this can be tricky. This can be a hard thing to think about. Tangent is y divided by x. So we need to find a y divided by x up there that gives us negative square root of 3. And that's not real intuitive. If I said find an x value that's 1/2, you can zoom right in and say, there it is. But if I say find a combination of points where you take y divided by x and you get negative square root of 3, I mean, that's a little bit more processing. So one thing we can do, even though the calculator isn't fully applicable here, we can see if we can use it for a hint. So inverse tangent, I'm sorry, was it square root of 3 or negative square root of 3? Negative square root of 3. Negative square root of 3, we get negative 60 degrees. All right, negative 60. Let me go up to the unit circle. Where would negative 60 be? Well, negative is this direction, right? And negative 60 would take us to 300 degrees. So that kind of tells us that one of our answers is going to be, where are we? Right here. Too much scrolling, sorry. Is going to be 300 degrees. I didn't use negative 60 because negative 60 is not between 0 and 360. All I did is I used negative 60 to help me find visually on the graph. Now, why is that the right answer? Well, again, this is x, this is y. Tangent is y divided by x. So if you take negative square root of 3 over 2 divided by 1/2, the halves cancel. You get negative square root of 3 over 1, which is just negative square root of 3. So that is what we were searching for. So the calculator didn't give us directly the answer, but it really helped us find on the unit circle. Now, if this is a right answer, how much you want to bet there's a second right answer? There could be. Sometimes there's only one. But here's kind of the tip. So this 330 or negative 60 has a reference angle of 60 degrees. If there's going to be another answer, it's either going to be on this 60-degree reference angle or this 60-degree reference angle or that 60-degree reference angle. Just a little way that trig works. Now all you have to do is look at the sign. I mean positive or negative when I say sign, not trig, S-I-N-E sign. This is a negative square root of 3. Well, this angle, if we divide those, is going to give us a positive answer. This one down here, if we divide those, two negatives equal a positive, so that's also going to give us a positive answer. But this one up here, xy, if we do y divided by x, that's square root of 3 over 2 over negative 1/2. Again, the halves cancel, gives us square root of 3 over negative 1, which works out to be negative square root of 3. So 120 would be our other answer. So it looks like 300 degrees is one answer and 120 is the other answer. Let me go down here. So I'm on this problem. 300 is one answer, 120 degrees is the other answer. Circle that so it's a little more visible. So that's 120 comma, make that look more like it's supposed to. 120 degrees comma 300 degrees. Let's check number 14 and make sure I didn't mess this up, because boy, there's a lot of complicated things going on here. There it is. Okay, so when you do number 13, ironically, you're going to want to clear the fractions by multiplying everything by 5 again. Nothing special about 5. The fact that mine had a 5, yours has a 5. But the idea is if you have a bunch of fractions in there, you can multiply by the denominator to make it easier to do. All right, let's go to number 16. How far are we? We're getting there. Almost done, actually. So another sign problem. Let's add 3 to both sides. We get negative 8 sine theta equals negative 4. Negative 7 plus 3 is negative 4. Because this is times negative 8, we're going to divide by negative 8. sine theta equals -4 divided by -8. Well, the negatives cancel and we can reduce 4 and 8 to 1/2. So it's going to be +1/2. I left a space there because the next step is going to be inverse sine of both sides. Cancel that out. So I am doing the inverse sine of 1/2. So sine, again on the unit circle, is a y value. So let's go up here and find any y value that equals 1/2. I guess I might erase all this other junk. Oh, why did I do it that way? That's the worst way to erase something. It's taking forever. But I already started it. Now I got to finish. Okay, so a sine value that equals -1/2. Ugh, I still got that to erase. Okay. Where's a y value that equals negative? Well, negative y value has to be in these two quadrants, right? Negative is below the y-axis, or below the x-axis. So y value of -1/2 is here, and here. And it seems like we've already done this problem. 210 and 330. I think this is the third time we've done this problem. Theta equals 210 degrees and 330 degrees. Check number 16. Whoa, that is not at all. Oh, I'm dumb. That wasn't -1/2. Duh, that's +1/2. Where did I get negative from? Why did I keep saying negative? Oh, probably driving you crazy, watching me do this, and you know in your head that I'm doing it wrong. Sorry about that. We need a y value that's +1/2. That's going to be in the upper two quadrants. So write what a y value that's 1/2 would be here and here. Okay, so that's 30 degrees, that's 150 degrees. There we go. 30 degrees and 150 degrees. Makes much more sense. Number 16, right there. Okay, sorry about my mistake. I actually did it right on paper, I just had it wrong in my head. Number 18, another tangent problem. All right, let's do this. I'm going to add 2 to both sides. I get 3 tangent theta equals 0. Divide by 3. Tangent theta equals 0. Do the inverse tan of both sides. Cancel out. Theta equals the inverse tangent of 0. So again, tangent is y divided by x. We want to find a y divided by x that equals 0. So in other words, the only way for this to happen is to have a 0 on top and then some other number on bottom. So go up to our unit circle, find any angle that's going to give us a 0 on top, right? Sine is y divided by x. If we want this to equal 0, we need the y value to equal 0. So that's going to happen right here and right here. Now I got to read my directions. I don't remember if I'm supposed to be in degrees or radians at this point. These exercises are in radians. So what are the radian answers? The radian answers are going to be 0 radians and pi radians. 0 and pi. So theta equals 0 and pi. Let me circle that and check the answer. Number 18, 0 and pi. Very good. Just out of curiosity, what would happen if I did this one on the calculator? So I'm saying I want to do this on the calculator just to see what happens. So function inverse tan of 0, and I get 0. So it gives me one of the answers, but not both of the answers. All right, last one, number 20. Let's start by adding 4 to both sides. 6 cosine theta equals 3. Divide by 6. Cosine theta equals 3/6, which you can reduce down to 1/2. Inverse cosine of both sides. Theta equals the inverse cosine of 1/2. Again, just see what the calculator does. Oh, and I'm supposed to be in radians here, so radians. So function inverse cosine of 1/2. 1.047. Okay, that isn't super helpful. Let's look at the unit circle. On the unit circle, cosine is an x value. So I need to find an x value that equals 1/2. Well, x value is positive 1/2, needs to be in either this quadrant or this quadrant. So where am I seeing this? Right here and right here. Those are both x values that equal 1/2. So that is pi over 3 and 5 pi over 3. Pi over 3 and 5 pi over 3. Theta equals pi over 3 and 5 pi over 3. Let me go back to Desmos for a second. What's pi over 3? Ah, it's 1.047. That kind of explains that answer. But then 5 pi over 3 didn't come up on the calculator. So the only way to get both answers is on the unit circle. And of course, there they are. Okay, so these are the simple ones. It's just, basically it's going to make you get good at using the unit circle. That's the reason why I asked you to have your own unit circle. So make sure you have on paper or on your iPad, save it as a photo, your own unit circle. Okay, it's really bothering me that I circled all my answers except for on these problems. So, gosh darn it. So circle an answer, circle the answer, no solution, answer. Okay, all right, going to stop there. I hope you made sense of this. You can do your assignment. If you have trouble, contact me, come to the Google Meet, whatever it takes. Otherwise, good luck, and I will talk to you later.